Hi, welcome to another short session of air engine research. There's been a question in comments from Zaycath, I believe that's how you pronounce it. Anyway, it's about using the exhaust air for air conditioning. I have also thought about it over the years, and the exhaust is pretty cool, and I think it could be used so long as it doesn't put a lot of back pressure on the engine. My first thought about using the air would be blowing it directly through the vents into the car. I think that would be okay, but could there be something in the air maybe to make us sick? I'm not sure what's done to compressed air that's used in scuba diving, but I know that is safe. And then the next thing I thought about was blowing the air through a heat exchanger, and that would keep the direct exhaust away from us, but it would add back pressure to the engine, and also it would require a fan to blow the air across the exchanger. Now there would be a certain amount of loss between the exchanging of the air in the car and the air going through the heat exchanger, so that would be a little less effective that way. And then as another thought, I thought about using the exhaust to turn a turbine that would turn a little fan blower inside the car and blow that through the vents in the car. That would also not have very little or no back pressure because of the turbine. The air just blows through it, and if it turns it, it's okay. If not, then it just goes past it. But anyway, a breeze would feel good even when it's hot. I've also tried to come up with some ways to give you an idea how effective using the exhaust air would be based on information that I could find on the internet about heating and cooling and trucks and things and what it would require. Using my 3-cylinder air engine, one rotation uses 3.7 cubic inches of compressed air at 200 psi. And then running at 2,000 RPM, it would use 9,336 cubic inches. And if you convert that into cubic feet, it would be 5.4 cubic feet. And then down a little lower, you take that 5.4 cubic feet times the pressure and divided by the, say, very little or no pressure on the exhaust side, and that would expand it to about 540 cubic feet. Now the specific heat of air of 1 cubic foot is 0.24 BTUs. So I've got 540 cubic foot times the 0.24 would give me 129.6 BTUs per minute. That's a long way from 15,000 what a small car would require. Cooling is just one of the things that we have to think about. In wintertime, we're going to have some sort of a heat system, and I'm not sure what we can do about that. But anyway, at the time being, I'm still working on just getting the engine to run as most efficient as I can, getting the pressure regulator to work with the higher pressure tank to reduce it down from my 200 psi running pressure, and just hopefully when the weather gets a little better, I'll get out and see how well that works. I've got most of the things completed, just not put together all the way yet. As far as the video goes today, if anyone sees any flaws in my thinking or in my calculations, please send me a comment for everyone to see so that we can come up with some practical and real solutions to the things that we talk about. But for now, thanks again, and hope you keep checking in. Till next time, we'll see you then.